Hey students! Okay, so this is part 2 of chapter 3 in Psych 218, Analysis of Behavioral Data. In chapter 3, we are talking about measures of central tendency. So getting right into it, we're continuing with the median as the second covered measure of central tendency. The median here, as the outline says, is the middle score, the midpoint. When, and this is key, when we rank or order the distribution from smallest to largest. So what that means is, if, for example, we have scores of 1, 2, and 3, and let's say we jumble these up a little bit, we would find the middle score by first putting these scores in order from smallest to largest and finding the middle score. And this is 3 scores, so the score in the middle is 2. And so the middle score here is the score that divides the group, and this here being the distribution. This is a group of 3. So the person in the middle is the second person. And so there's one person to the left of the middle person, and there's one person to the right of the person in the middle. So the median really is like the middle, as in the one person or score that divides the distribution into 2 parts, 2 equal parts. So there are ways to calculate the median or to figure out where it is in the distribution. And the key difference is for an odd number of scores versus an even number of scores. And we're going to talk about this now, starting with the odd number of scores. Again, the steps are getting all the numbers of the distribution, all the scores, and then put the scores in order. So in this case, we already have some scores in order, 3, 5, 8, 11, 10, and 11. And so we want to find the middle score. Now, there is a mathematical expression for this. And so what we do is we find the number of scores, the sample size or the population size. In this case, we call this sample size n. And if we just go use an odd n, an odd number of scores, and we try to divide 5 by 2, we're going to get 2.5. So instead what we do is we add 1, 5 plus 1 divided by 2. So here's 6 divided by 2, and that's 3. And the third score here is the middle score because there are 2 scores on the left and 2 scores on the right. So the third score is the middle score when there are 5 scores. So what we're using the math for isn't to find the score itself, but to find the position of the distribution, the nth number, the number we're looking for. So if it's 5 scores, we're looking for the third rank person from smallest to largest. And then we read the value, the x value of that person's score, and it is 8. And so the median is 8. It's the third score, not number 3, and the third score is 8. So that's how we do it for odd numbers. So for a test here, we can try a simple one. If instead of 5 scores, if n is not longer 5 but 7, what would be the median position? So the median here would be n plus 1 divided by 2, so that's 7 plus 1 divided by 2, and that's 8 divided by 2, and that's 4. So it's the 4th score. So if there was a 4th score, I'm going to pretend to give 2 more like this. So then the 4th score here would be 10. So the 4th score, and in this new distribution, you'd have 10. So that's really the gist of it in terms of using an odd n when there are an odd number of scores and looking for the median that way. That's the easy one. When you have an even number of n, it gets a little bit harder because the score itself doesn't technically exist. Because we're looking for something in the middle that splits the scores, the distribution, in two halves. So if there are an even number of scores, then there's no really an individual score that divides the halves. Let's take a look at this here. If there is a distribution of 6 scores and we put the divider right in between those 6 scores, it doesn't hit anything. And so there are free scores on the left of the divider and there are free scores on the right of that divider. So what would we call the median then? Instead, we would look at the score to the immediate left and right of the divider. So in this case, we have found the position where we want to put our divider. So we first want to find the middle pair. And that is, first we look at the lower number. The lower number would be n divided by 2. And because there are 6 people, and 6 divided by 2, that's 3. So we're looking for the third person, third score. And then the upper number, well, that's n divided by 2 plus 1. Well, we already know it's 6 over 2 plus 1. So that's the fourth score. So we have it, the fourth score and the fifth score. With this pair, then we find the mean of that pair, or the average of that pair. So we go 4 plus 5, adding the scores together, and because we're adding 2 scores, and we want to find the mean or average those scores, then it's 9 divided by 2, and that's 4.5. So the median score is 4.5 for this distribution that has an even number n. Again, in this case, the median isn't an actual score, but it is between the third and the fourth score here, averaging the middle pair. So remember, for an odd number n, you will find an actual score, but for an even number n, you will average the middle pair. The lower number being n divided by 2, and the upper number being n divided by 2 plus 1. So we can do a quick test here. So instead of 6 scores, let's say we have 8 scores. So if n was equal to 8, what are the upper and lower numbers? Again, you can use math to really do this thoroughly. So for example, the lower number would be n divided by 2. So that's 8 divided by 2, that's 4. And then the upper number is that number plus 1. 8 divided by 2 plus 1, that's 5. So the fifth score and the fourth score, the fourth score and the fifth score respectively. So let's pretend there are 2 more numbers here like this. And so we would average out 5 and 7, the fourth and the fifth. So 5 plus 7 divided by 2, in this case is 12 divided by 2, and that's 6. Again, it's the average of the middle pair. Again, that number doesn't exist, or at least is not an actual score in that distribution. And that happens when there is an even number n, or the sample size has an even number of scores. One more thing about the median is that when we are dealing with a median for a continuous variable, where, for example, the x values have decimal points between them, so we're talking about things like 1, 1.1, 1.2, 1.3, and those values exist between, let's say, 1 and 2, then the median must be a precise median. And there is a way to calculate this precise median, and we'll first go with the outline and see what the points say. Because the continuous variable can be infinitely divided, the people that actually score those values may not necessarily score on those rounded middle numbers. So for example, we use height again. Again, it could be 149, 150, 151. But somebody may have 149.9, and then we count that as 150. Let's say we quote unquote round up. and then we have the upper and lower limits of 150. And then, so let's say somebody could have 150.2, and that's that's below the upper real limit of 150, and so that's still counted as 150. So with the same concept in mind, we apply that to calculating a precise median that is located in the interval, defined by the real limits of that value. So that's what the point's saying here. So to do this, we need to determine the fraction of the interval that we need to locate the median. That still does its job. That is to divide the distribution by exactly half. And the mathematical expression looks like this. We want to find a fraction in that interval. So we can still find the position, but we want to find the fraction of that position by doing the following. We want to find the number that's needed to get 50%. And the fraction of the interval still needs one more thing, and that is the number of the interval itself. So the best way to show you is with the next slide here. So here we have the scores, and I'm going to actually write down the frequency distribution for this. So we got 7, 6, 5, 4, 3, 2, 1, and 0. There are no zeros. Okay, there's 1, 1, 1, 2, 1, 3, 4 4s. We can count that. No 5s, 1, 6, and no 7s. So we can actually count this, double check. 1, 2, 3, 4, 5, 6, 7, 8 scores. Cool. So we know the total is 8. Now, we don't need to add these up. We're not calculating the mean here. That's one less thing for us to do. One more thing I can do here is to just write the scores in ranks. So you can see here there are 4 4s and 1 6. Again, 8 scores. So I'll use Roman numerals here. 2, 3, 4, 5, 6, 7, and 8. There. Okay. So if we use the formula that we know, and there are 8 scores, we know then here. Okay, we know it's the 4th and 5th score. So here our lower value is, I'll write this again. This is a little bit messy. There you go. 4, nope. 4 is the answer. 8 over 2 is 4. And the upper number, or the upper pair, plus 1, which is 8 over 2 plus 1, which is 4 plus 1, which is 5. Cool. So we're looking at the 4th and the 5th score, and we average those out. Well, 4 plus 4 divided by 2 is 4. Well, 8 divided by 2, so that's 4. Okay. However, because we are working with a continuous scale, what we've done so far will be fine for a discrete variable, but because the variable itself is continuous, and it's a ratio scale because it has an absolute 0, the precise median is not necessarily 4. And in this distribution, it isn't. And there's a way to think about this logically. So, for example, let's say if the scores were not all exactly 4. Remember, it's continuous. So some person could have, and I'll put in the limits first. So the number 4 here would have, and this is, let's say, 3 and 5. So there is a lower real limit of 3.5 and a upper real limit of 4.5. Somebody could score 3 3/4. Somebody could happen to score, I don't know, let's make it close, 3.99. Somebody could score 4.25, and somebody could score 4.49. Now, each of these could be and would be counted as 4 on the scale, and it might read like this. I'm not going to change the other numbers, but I'm going to change the 4 numbers and then 6. So you see, you still rank these. And I just made up these 4 numbers right here. But the point is, on a continuous variable, in this case a ratio scale, yeah, those numbers are possible. And so in order for us to find a precise median, we need to find a score, an actual score on this continuous variable ratio scale that divides precisely the distribution into halves. 4 wouldn't really do it because if we go 4, then really we would be taking a portion from the right side of the distribution, and it would no longer be the median. It would not be balanced. So for us to do this, we need to determine what value, and we can go back here. We need to determine the number that is needed to get 50%, and then the number of people or scores that is in that interval. Okay, so the number we need to hit 50% is n divided by 2, which is 8 divided by 2, which is 4. And so that's one thing. And then there are 4 people or 4 scores in this interval right here. We can count them. 1, 2, 3, 4. So to find the fraction in that interval, and we're talking about this interval right here, the 4, which is between 3.5 and 4.5. So the interval itself is 1. But we want to find the fraction in that interval that is the middle. And so it's going to be somewhere between 3.5 and 4.5. And this is how we're going to do it. So we know there are 4 blocks in that interval. So again, I'm going to put 3.5 over here on the lower real limit and the 4.5 here in the upper real limit. And we know there are 4 people that make up this interval. 1, 2, 3, 4. And we know at the same time that there are 3 other people or 3 other scores below this score, the 4th score, and this is the 5th, the 6th, and the 7th. Okay, and then there's one more score, which is the 8th score right here. It's the 1st, 2nd, 3rd, and this is our 3.5 lower limit and 4.5 upper limit. I'll remove the circles to make this less confusing, and I'll actually put this a little lower. So this is our 4 right here. And then the limit of this here, this part is 3.5, the lower limit, and this part here is 4.5. So again, our median would be right here in between the 4th and the 5th score. And so the fraction at this point to reach here would be exactly 1/4. So that's why we see 1/4 here. So we, at this divider right here, which I'm making a thicker line, you have 4 scores on the left, 1, 2, 3, and 4. And then on the right side of the divider, we have 4 more scores, 5th, 6th, 7th, and 8th. So the value between the interval of 3.5 and 4.5 in that limit, the upper and lower limit of the interval 4 for this continuous variable, well, 1/4 of 1 is 0.25, so 3.5 plus 0.25 is going to be 3.75. And so the median then here has the value, not 4, but 3.75. And in terms of position, that's how we find the precise median, taking into account 2 things. One, the concept that the scores that we record are not necessarily 4. They are scores within the upper and lower limit, real limit of 4 for this continuous variable. And 2, we still need to find the divider precisely for this continuous variable, and we do that by following the instructions and go, oh, we need to know where we can put the divider and where in that interval and what fraction that would be to put in that divider. So again, a precise median for a continuous variable is not necessarily the same, especially if the distribution is skewed, or if there is more than one score in that interval for the continuous variable. So you might want to keep that in mind as well. However, the formula remains the same, and there is an extra step to finding that fraction in the interval that you're looking for when you want to find the precise median in a continuous variable. What I strongly recommend for this is, if you want to practice a precise median, you would find more information in the textbook that covers this in even greater detail, and practice questions of it. And you can still find the precise median actually if you change the variable from discrete to continuous. Most of this course would look at the variables technically as discrete. However, when you're asked to calculate a precise median, you know you're dealing with a continuous variable for x values. So then, there you have it. We have just finished discussing the median and the mean, or the mean and the median. And so those are the first two ways we would define as middle, and those are the two more logical ways to define the middle. The mode isn't really the middle unless it happens to be a normal distribution, or at least a distribution that's symmetrical with one peak. It happens to be in the middle. Well, of course, being symmetrical, that would be the case. However, the mean and the median are middle scores, but each has its own definition. The mean is the balance point, or the pivot that we talked about. It is quite sensitive to changes in the distribution, and it is defined by the distances between the scores, and it is often not the midpoint of the scores. It doesn't divide the scores in half, but it does balance the distribution as a pivot. The median, though, is the divider. It's the middle score, and it is defined by the number of scores. So you need to count the number of scores for both, but the median is defined by that number. You want to find half that number. And it is often not the balance point of those scores. So if you were to use the median as a pivot, even though it splits the score in half, the weight of the scores, that is the value of x, can tip the scales, so to speak. So remember, mean is the pivot, the balance point, and the median is the middle score. However, both of these are measures of central tendency in that they are both trying to figure out what is the middle score as an expected score. So here's a comparison between the mean and the median, and this would put our point forms in the previous slide in a more concrete graphical way. Here you see 6 scores. So we can count them 1, 2, 3, 4, 5, 6. Again, we can calculate the precise median if we must. But here, we're just going to assume that we're dealing with a discrete variable this time. And just look at the scores as they are to keep things simple. Again, I could do the frequency distribution here. So I'm just going to skip some numbers. I'm just going to do 12. There is 13. 13, 12. I'm going to skip a few all the way down to 3, 2, and 1. So there's no 13. There's 1. There's 1 12. And then there are 2 3s and 3 2s and no 1s. Again, I could rank these 2, and I should, for the median. 2, 2, 2, 3, 3, and 12. So naturally, you can see n is 6, and the lower number here is going to be, well, 6 divided by 2, 3. The upper number here, well, is 1 plus that, so that's 4. Okay, I'm going to skip a few of the arithmetic here, having done this enough times. And once you do enough, you can too. But if you want to be absolutely safe, and I recommend this, just doing it. And yeah, first you get good, then you get fast. But if you do all the steps and you get good at it, you'll get fast anyway. And it's always good to do all the steps. Anyway, I found the third and fourth number. And so I averaged those out. So the median here would be, well, 2 plus 3 divided by 2. So that's 5 divided by 2. So that's 2.5. 2.5. And that checks out. We can also do the mean. So I'm going to add up all these scores. 2 plus 2 plus 2 plus 3 plus 3 plus 12. So here, sigma x would be, and I can do this, make this a little faster. So it's 12, 6, and 6. Well, that's 24. Again, you can check by adding all of these up. Well, 4 plus 2 is 6, plus 3 is 7, plus 3 is... Ooh, did I do this right? Let me double check. Okay, 6 plus 6. Well, that's 12. There you go. It's still 24. So I said 4 plus 2, that's 6. Ha! Plus 3 is 9, not 7. Plus 3 is 12. Yeah. So it's always good to double check. Anyway, 24. And the mean is, divided by n, 24 divided by 4, 6. 6 scores. That's 4. That also checks out. So you can see two things here. One, we had an extra practice if you need it. And again, if you are unsure, it's always good to practice. Notice, though, you can also describe the shape of this distribution. And if you're thinking positively skewed, you're right. Well, there happens to be a score right here in the extreme positive end. We would call this an outlier. And because it's outside of the interquartile range, that's something that's also covered in statistics class, but not this course and not this chapter right now. And it pulls the average to the right because the score is further towards the right. And so it pulls the mean further to the right, and the pivot would be here. This is our pivot. And the median still divides the score in the distribution in half, but if you put the pivot here, it would not balance. It would tip. It would actually tip towards the positive direction because there's more weight that way. So the mean balances the distribution, and if you have skewness in your distribution, the mean would move towards the direction of the skew. That is, whatever score is more extreme, you're going to get the mean moving towards a direction. If it's extremely high, if you get some extremely high scores, the mean is likely going to move to the positive direction. It's going to be higher. If you can get some extremely low scores, then the mean would be lower. So the median and the mean, when the distribution shape changes, would also move around. So here's some learning checks for this. Question 3 is a true-false two-part question. A, is it possible to have more than 50% of the scores in the distribution to have values above the mean? That's A. Is it possible to have more than half the scores above the mean? And B, is it possible for more than half the scores to have values above the median? Take a moment and you can review the last slide, for example, or work out some different distributions and look at these ones. Like this is another one, and this is another one, and so on. And we go back to our learning check. So, is it possible? Well, for A, yes, you can. And if you're looking at this and looking at part B and going, no, that can't be right, you're absolutely right. It's false. The definition pretty much speaks for itself, but just to make sure, yes, you can have, for the mean at least, yeah, because the mean is a balance point, and if there are distributions where it's negatively skewed, then or positively skewed, then you can have more or less than 50% of the distribution being above or below the mean. So here's an example of this for A. Here we see a positively skewed distribution, and we can see here the mean is the balance point, and the median is below the mean, and so half of the scores would be here on the left of the median, but then you can still have more scores on the right of the median that is still below the mean, and the mean itself really has only one value to the right of it. So if we were to reverse this image, and see if we can answer the question that, yeah, is it possible to have more than 50% of the scores in the distribution to have values above the mean? We can. So let's say if instead we were to flip the distribution, I'm going to just shade it in here like this. So I'm going to go do a mirror image of this distribution like that. Okay, so our new values then would be 2, 11, 11, 12, 12, 12. So quickly here, sigma x would be, okay, 22, 24 plus 36. Well, that's 60. And divided by 6, 60 divided by 6, well, that's 10. So we would have a mean right here. And yeah, it would indeed be a mirror image. And now the mean is right here. And the median would be 11. And the median here would be 11.5. Again, assuming that it's a discrete variable. So here you have a case where there's only one score below the mean, and that's 2. This guy. And then we got 5 scores here, 5 blocks with 11, 11, 12, 12, 12. That is above the mean. So it is possible. For B, question B, it's pretty obvious. Because the median by definition divides the scores in half, the distribution in half, so you can't have more than half the score above the median. So that was the question there for us to help us distinguish between the mean and the median. Last bit is the mode in terms of the free measures of central tendency. The mode here is pretty straightforward. It's the most common score with the greatest frequency. That's about it, really. The other points say you can use the mode for any scale of measurement. It always, always, always corresponds to an actual score in the data. So the median does so more often. The mean would be slightly less, perhaps, but neither the mean or the median always corresponds to an actual score in the data. And whether the mean or the median corresponds to an actual score depends on the shape of the distribution. But for the mode, it doesn't matter what shape the distribution is, there's always a value because you're simply counting them to see which one has the most. The only way to get no mode is if all the scores, all the participants only scored like the same number of scores. Like everybody had one score. So then there's no mode. Or if everybody scored, the two people, pairs of people that scored the same score. There'll still be 2. Every score has 2 people on it. So they still have no mode. So that's kind of the only situation. But the mode always corresponds to an actual score when there is one. And there the next point here is that you can have more than one mode. So for example, you can have a bimodal distribution that looks like this, that has two peaks, as we've seen in the first slides. You can have more if you want. I mean, there are cases where, certain groups of people score in certain range, and then so you can have multiple peaks that way too. But more likely than not, you're going to get a normally distributed or some type of unimodal distribution, and bimodals can happen if something, for example, is both too easy and too hard. So here's an example of a bimodal distribution. Here is a tone identification score. This may have to do with people's hearing ability, perhaps musical ability in terms of tone, accuracy. And so there are two groups of people in the sense that there are two modes. Some people perform or have higher scores on the right. There's a whole bunch of people scoring in the 10s and 9s. And then there's another mode here where there are people that are scoring in the 2s and 3s and maybe 1s. And then there's very few people that happens to be in the middle. So the mean would be somewhere between here, and the median would be somewhere in the middle. But the modes, there are two. 2 and 10. Now, technically, this has one mode, and this is the most common one right here. There are 8 2s and 7 10s. So the true mode here would be 2. But there are indeed 2 peaks, which you can see here in the picture for this distribution. So this table here that you see gives us an overall chart and some guidelines as to when you should choose which central tendency. And there are 2 columns here. The first column is the central tendency measure. You have mean, median, and mode. And then the second column gives you some guidelines as to when you should choose this measure. It says you should choose this measure if, right? And then the last column here talks about when this particular measure, mean, median, or mode, can be misleading. So this would be best for you to review on your own. I will explain each one, but if you want to really get the table down pat, as in really be able to explain to yourself and explain to others what the measures of central tendency are, when you should choose them, and how they could be misleading, is go through each one, work out some distributions, and see if you can do a checklist of these points for yourself. Like, for example, for the mean. Well, by calculating the mean, I can calculate sigma x, and I know the value of each score. Yeah, I should use the mean. Okay. For the median, well, if I look at the distribution and I know I got some extreme scores, and you might think, wait a minute. If I have extreme scores, that could really pull the average in that direction, whatever the direction of the extreme score is. So we know, okay, the extreme scores would make the mean this misleading, and extreme scores mean the distribution is skewed. So when I have extreme scores and the distribution skewed, I should use a median too, or look at the median a little bit more closely. If there are undetermined values, like, there are values that appear to be missing, then yeah, it could be misleading if you're looking for the mean, and you would use the median if there are undetermined values or missing values. If you have an ordinal scale for your x's, yeah, well, it's ranked, so you want to use the median too, because you automatically rank the scores. Open-ended distribution, as in, it could be, the values can go really high. It's open-ended. So for discrete variables on ordinal and nominal scales, it would be misleading because, well, it's not continuous. So the mean is a mathematical value, and it works best for continuous variables and an interval and ratio scale. So when you work with other scales, mode is good because you simply have to count them, and the scale, there's no order to them, it's just categories. Discrete variables are also good for mode because, well, you're not looking for on a continuous variable or an interval ratio scale. You just want to know, like, hey, with the mode, oh, what's the most frequent score? What's to be expected? It could be something like, oh, what would people choose between Coca-Cola and Pepsi? Well, these are discrete variables. It's just Coke and Pepsi. You wouldn't say technically which one's better, although you might have your preference. But if you simply want to know, like, what do we expect people to pick? Yeah, just look at the mode. And mode is useful when you want to describe the shape, because the mode always refers to an actual value in the data by looking at the shape of the distribution. Conversely, if you use the mode, it would not be as good for interval or ratio data. And however, if you happen to find the mode, especially for normal distributions, the mode is automatically there, and so it would complement the mean and the median. And the last bit for the median is, if you happen to know the value of every score, and if you can calculate sigma x, that's more useful for the mean. And if you know the value of every score, then the median could be misleading, because, well, you're going to compare two measures, both the mean and the median as well. So that's it for the table. And again, working out this table and working out different distributions, different shapes, symmetrical, positively skewed, negatively skewed, bimodals, and figuring out the central tendency of, well, each measure of central tendency for each of these distributions would really help you apply knowledge here. And you can answer your test questions. You can look at distributions much quicker by doing this work. There's no substitute for that. If you only listen and follow along and you haven't done work, it would be not the same level as someone who has done the work and worked with the distributions. And again, this course is a practical course, and you will need to work with distributions because we are dealing with people, and the people, we measure them and research them, and these deal with actual data. That's why the course is analysis of behavioral data, and these three measures are part of that analysis. This picture shows a way that you can show large gaps in data. If you work with schematics, this little zigzag here means there's more values in between them, but don't need to show them, possibly because the values are missing, or there are no values in, like, for example, between 0 and 10, or between 15 and 100. So this would be, again, an outlier, a very extreme outlier at that, and you can think, oh, well, this looks like a positively skewed distribution, and you can think about what that means for the mean. And because this value is there for 100, this is going to pull the average way up. You would have expected somewhere, well, the median would be somewhere here, 11, and the mean would be somewhere here, like between 11 and 12. But because the 100 is there, the mean would be somewhere way past this point. It would not be an actual number if there are no numbers or no scores between 13 and 100, and so on. So again, two things that this picture shows. One, the zigzag shows you how to show large gaps in data on the x-axis. And two, again, another practice for a particular type of distribution. In this case, a positively skewed distribution with a very high extreme value, a very high outlier of 100, which pulls up the mean. This slide talks about how you can view means and medians in a line graph. This would be a frequency distribution polygon. And so you can still calculate the mean and median for this. So again, you can try this out as well. And the continuous line is used because drug dosage can be partial. Like you can have half a dose, or 1.5, or 1 1/4, or 2 1/3, and so on. So then now we look at central tendency and distributions themselves. And so in different distributions, you're going to get different measures of central tendency, and they'll behave differently. So in a symmetrical distribution, something like this, for now we'll just use a bell curve, The mean and the median obviously would have the same value, and if there's only one mode, then that value, that mode, would be the same too. In the case of a bimodal distribution and that is symmetrical, well, there are two modes, so the mode doesn't correspond to the mean and the median, but the mean and the median for symmetrical distribution would be exactly the same. So this distribution can apply to one mode, multiple modes, or even no mode at all. It could be something just like this. Everybody in the distribution had one score. This could be blocks, you see. But it's still symmetrical. So that's a symmetrical distribution. And when the distribution is symmetrical, the mean and the median are the same, or the same in value. And if there's one mode, the mode is that value too. So here's an example of this. I drew it out, and the next slide shows you an example as well. In skewed distributions, that's where things get more interesting. That's where the mean, median, and mode start to quote-unquote move around, depending on the distribution. So there are two slides here that will show you. The first one is using point forms. So it will tell you in words what the positioning of the mean, median, mode will look like. And here is the picture form, which can help you understand much faster if you learn with pictures this way. But taken together, and if you try it with different distributions and calculate it, you can see for yourself and, teach others too how the mean, median, and mode, change when the distribution shape also changes when there's skewness. So here in concept, this is what happens to each measure of central tendency. As we explained, because averages can be pulled, this is where, in your course, again, someone pulled the average. Usually that means somebody did really well, and that makes the class sad because the average is now higher than what you would like, especially if the course is scaled. Anyway, the mean is pulled or moves towards the skew, towards the tail when there's an extreme value. When the distribution is skewed, the mean always moves towards the skew. So if it was a positive skew, the mean would move to the right. If there's a negative skew, the mean would move to the left. The median then would be between the mode and the mean. So the mean is the one that always moves. And we talked about how sensitive the mean is when the distribution shape changes. The mean can also change when the scores change, but we're focusing on skewness right now. When there's a skewness, the mean moves towards the direction of the skew. And we explained that. Positive skew means the average would move towards the right. I'm going to use average here because I'm using too many means. If the distribution is negative skew, the mean would move to the left. The median, another way to help you remember this word, is that it's going to be in the middle. It's going to be in between, in the middle of the mode and the mean. The mode doesn't really move at all. The move stays at the peak where it is. So in a positively skewed distribution, you know the mean is going to move to the right, and you know the mode is going to be lower than the mean. So in that case then, the mean would have the bigger value, and then the median, and then the mode, provided that they're all, above 0. In picture form, as you will see in the next slide, a positive skew would be like this. The mean would be somewhere over here. I'm going to use population parameters. And the mode is here. And the median is here. I'm just going to write MED. And the mean would be here. So again, if you're trying to think about this, a good first step is to always remember where the mean moves. Positive skew would move the mean to the right. And then all the other measures are going to be lower than that. The mode is the lowest, and the median is going to be in between, the middle of them. If it's a negative skew, then the mean would move to the left, and then you'll have the median in the middle, and then the mode being the highest value in this case, because the mean has moved to the left. So yes, the mean would have the smallest value in a negatively skewed distribution, and then the median would have the next smallest value, and then the mode. I'm going to change this to mode. And then, yeah. So that would be the case. Another thing to change. Okay. So case in point, this is a picture. Again, you can see, if you already got it by now, you can press right, maybe. It would skip the next 20 seconds or 10 seconds or so. But for those of you who still may not understand yet, this is a picture that shows it as clearly as possible for this video. Again, a positively skewed distribution would move the mean to the right, and then the median's in between the mean and the mode, and then the mode is where it is exactly where the peak is. When there's a negatively skewed distribution, the mean would move to the left, the mode stays where it is at the peak, and then the median is between those, between the mean and the mode. Again, a good practice is just draw it out. Oh, okay, well, positively skewed. Oh, I know the mean's going to be here somewhere on the right. I looked at the mode. That's pretty simple. It's the peak. Can't argue with that. And then the median would be somewhere in the middle. Same thing with a negatively skewed. Okay. Well, I know the mean is going to go to the left. And the mode is where it is, where the peak is. Pretty straightforward. And then the median is going to be in the middle, between the mean and the mode. So that's how the relationship works between mean, median, and mode when the distribution is skewed in either the positive direction or the negative direction. So here's some learning checks. Question 4. A distribution of scores that shows the following. The mean is 31 and the median is 54. Taking these measures into consideration, what would you say about the distribution? The distribution is probably positively skewed, negatively skewed, bimodal, or open-ended. Again, you can take a look at the last slide. Here you see the median is larger than the mean. Then you can think about, well, in which direction has the mean been pulled? Remember, when this distribution is symmetrical, the mean and the median are the same. So if the mean and median are different, that means the mean is either larger or smaller than the median. You can think about which direction the mean has been pulled, and whatever that direction is that direction of the skewness. So, if you answered negatively skewed, you're right. The mean is smaller than the median. That means the average has been pulled down in the negative direction. That means there's a negative skew, that is a negative tail in that direction, in that distribution. Okay, some more learning checks, and then we're done. Question 5 is two-part, true, false. A, the mean uses all the scores in the data. So it is the best measure for central tendency for skewed data. True or false? B, the mean and median have the same values, so the distribution is probably symmetrical. Take a moment and think about this one. For A especially, you can refer to the table if it's new to you. Or think about the nature of skewed data. What happens when a data is skewed? And what happens to the mean when the distribution is skewed? The average gets pulled, right? You can think about that. And then for B, you can think about, hey, what does it mean when the mean and the median are the same? So if the mean is not pulled in either direction and it's the same as the median, what does that say about the distribution? So for A, if you answered false, you're right. As in, no, the mean is probably not the best measure to go because the average is pulled. Yes, the mean is still the balance point, but it's not really the middle score. Especially if the skew is very extreme, as in there's one really big outlier, like a whole bunch of scores in the 11 and 12, and then there's a score of 100 somewhere. For B, yes, when the mean and median are the same, the distribution has to be symmetrical. That it's not just probability, it has to be by definition. because, well, both sides of the distribution have, equal portions, and the mean, when it's exactly the same as the median, well, there's only one explanation. The distribution is symmetrical. So that's it. That's it for our chapter 3. We have covered these 6 learning outcomes. We have explored and explained, that will help us understand the purpose. I'm going to use explain here. And I'm going to change this to explain the purpose of measuring central tendency. That is to get expected values, which involves the middle value, or the most common one. We have defined and computed or calculated the 3 measures of central tendency, the mode being the easiest. You just got to count them. But with the mean and the median, the mean is defined by the scores, and the median is defined by the number of scores. So we've talked about this. Number 3, we have described how the mean is affected when the scores are changed somehow. Again, you could just change one score, add or subtract scores, or just change all the scores, by adding, subtracting by a constant, or multiplying, dividing them by something. Okay. Number 4, we have described the ways that how each measure of central tendency is used appropriately and the ways it could mislead. So you can refer to that in the table. We can also covered how to explain how these measures of central tendency are related to each other in symmetrical and skewed distributions. You may think back to the learning checks that we had, that symmetrical distributions have the mean and the median as exactly the same. And if it's a one mode symmetrical distribution, mean, median, mode are the same value. But when it's skewed, that's where things get interesting. The mean gets pulled towards the direction of the skew, and the mode is where it is, you see, as the peak, and then the median is in the middle of that. And then we looked at this in terms of graphs, so we can interpret the graphs as well as drawing the graphs. And when it comes to drawing the graphs, we can go back to our chapter 2, making frequency distribution tables and frequency distribution graphs, including histograms, bar charts, and polygons. So that's it for our chapter 3. We covered it in 2 parts. I still continue to aim to keep everything in an hour, but it's probably going to be impossible. And this brings us to a sort of a teaching point here. While I have this attitude of trying to teach these chapters in 1 hour for brevity's sake, you may notice that the depth of these statistical concepts, even though the math seems simple right now, and even if the math seems simple to you all the way up to chapter 12 or 14, when we talk about things like ANOVA and correlation and regression, still, it is the logic that we use. It is the process and the procedures that we employ, that we use and utilize for, answering questions and analyzing behavioral data. That's where we can deal with real life numbers and work with these distributions. So we have finished our measures of central tendency. We can now use statistical procedures to find expected values. Next time, we're going to look at chapter 4, which deals with variability, and answer questions like, hey, what is the spread of the distribution? How far apart are the scores from each other? Not just the range, or not just how far apart is the lowest score from the highest score, but also like, hey, how far apart are the scores from the mean, and what should we expect from that? So stay tuned. Again, no substitute from working from a textbook and writing your stuff by hand. There's no substitute. You need this. You could type if you want, but you need to do something with your hands and some sort of writing material, be it pen, paper, or notebook. Again, phones would be much harder to work with this. Tablets are also harder because it's smaller. If you got a stylus, great, work with that. Writing is still useful. Probably always will be. So keep going. You can do this. Free sources of information that you can get if you have questions. Again, the textbook has the most detail, and works with you at your own pace. Next is the videos, which you can pause and fast forward and rewind or get to the part you need to listen if you prefer a listening approach to learning and watching, but still not a substitute for the textbook because there are problems and practice questions there that you can work with, and the details are more extensive there. And the last bit is, if you're still stuck, you can ask me direct questions about particular parts of these chapters. So again, we're here to help you out, and this is again chapter 3, and we'll see you in the next one for chapter 4.